This is question 11 from tutorial sheet 5 of Engineering Dynamics. In this question, we've got a lorry crashing into a stationary car, and after the collision, they're both due to move as one object, moving off together. So let's look at what's happening. We're also asked at the end to calculate the distance they travel if they reach rest after 8 seconds. So we say this is our lorry here, traveling along. This is our car here. It's currently stationary. The lorry weighs 2,000 kilograms. The car weighs 1,000 kilograms. The question, the lorry is traveling at 50 kilometers per hour. And if we do our unit conversion for this, we find that that's equal to 13.889, 3 decimal places, meters per second. And afterwards, what we're going to have is two masses together, continuing to move with a total mass of 3,000 kilograms here. We get that from our 2,000 plus 1,000 here. So let's have a look at what's going on with our formula. M1U1, the mass of the lorry times its initial velocity plus M2U2 for the car is equal to M1V1 plus M2V2. So on the left-hand side, we've got 2,000 times 13.889. We know that the velocity of the car is 0, so its momentum is going to be 0 because 0 times anything is 0. On the left-hand side, we have 2,000. Now we can replace V1 with VF because we've got a combined velocity from the same, and we've got 1,000 times VF here as well, our final velocity after the collision. So let's do a bit of tidying up here. We're going to say 2,000 times 13 point, again, 2,000 times 13.889 is equal to 3,000 VF. So VF is equal to 2,000 times 13.889 divided by 3,000. There would have been nothing wrong with multiplying through 2,000 by 13.889 first, but I just thought I would get into position where we could get it all into the calculator in one go. And if we do that, we're left with 9.259 meters per second. So that's the speed at which they're moving off at. And again, common sense check here. If the lorry had a speed of 13.889 and it's colliding and picking up the car, it's got more mass. For momentum to be conserved, the velocity is going to have to be less than that as well. So we're told then that they come to a rest 8 seconds later, and we're asked to find out how far they travelled in that time. Well, if they're starting off, this is the second part of the question. There's not really a letter for it, but it draws the line here. Second part of the question, the initial velocity is what we worked out in the first part, 9.259 meters per second. Our final velocity is going to be 0 meters per second. And the time we were told is, back up, 8 seconds. Well, again, we can go back to our equations of motion to find one for S. We've got this formula here, S is equal to U plus V divided by 2, and all of that multiplied by time. So we have 9.259 plus 0 divided by 2, and that's all multiplied by 8. And if we put all of that into our calculator, we're left with the distance travelled being 37.037 meters. And that is the final part of the second section of question 11 and gives us our answer there.